An epidemic endemic, so what we call outbreak. Currently, outbreak is considered an infectious disease that arises at a particular time and location, and an epidemic is considered a rapid spread of diseases in a majority of people of a particular population group in a short period of time. Outbreak and epidemic are actually used as the same concept. Endemic is considered infectious diseases that arise in a particular region. Pandemic is an infectious disease that spreads globally, so COVID-19 is considered a pandemic. An example of an epidemic infectious disease is, in 2014, Ebola was prevalent in places like Sierra Leone, West Africa. And from December 2018 to May 2019, measles was prevalent in regions like Daegu and Ansan. Endemic disease is a common infectious disease that arises in certain areas. Currently, cholera is still prevalent in Africa and Southeast Asia, particularly India and Bangladesh. When you go abroad to volunteer, it is important to take measures in advance, such as understanding what epidemics are in the region, what endemic infectious diseases are always present, and prepare preventative measures like vaccines and medicines. And that's why outbreak, endemic, epidemic, and pandemic are different concepts but continuously present. When a trend begins and eventually disappears, it's considered an outbreak of an epidemic. But if it doesn't disappear and continuously occurs in a region, it's an endemic. It becomes an endemic disease, and if it spreads widely on a global scale, it becomes a pandemic. So for a pandemic, a large number of people in a region get it and die from it. In a way, a pandemic is the worst form of an infectious disease, and human history suffered a lot from pandemics. The disease that caused the most damage is smallpox. It killed 300 million people. Fortunately, WHO vaccinated smallpox, and by 1980, smallpox disappeared worldwide. So smallpox is the only infectious disease that has been extinguished by vaccines. In 2009, there was still 16% left, and seasonal flu circulates every winter. And then the Black Death that killed about a third of Europe's population in the 14th century. So over the past century, if you look at pandemic cases, Spain's pandemic in 1918 occurred during World War I, so it spread around the world and killed 50 million people. In South Korea, 7.5 million people were infected and 140,000 died. Then why does a pandemic begin? There are several factors, but in the case of COVID-19 that started in Wuhan, it started from bats, then passed through a middle host like a pangolin and infected humans. There are many emerging infectious disease pathogens in jungles. If you're exploring a jungle and get bitten by animals like bats or civilcats, your body will be infected. Also, if you get infected, you have to take the plane. 100 years ago, it took 100 days to travel around the world. Now, you just need 1 day. An infected person gets on a plane and spreads worldwide. When a pandemic begins, there's a lot of damage. A lot of people get infected and die. And a lot of manpower is consumed on public health. Also, when we go into a lockdown and social distance, stores close down and we can't travel. Tourism and trade will also reduce, and the economic damage will be great. Sports, culture, and other events are now canceled too. It has a huge negative impact on the global and national economy. An infectious disease is no longer about health. It also has negative impacts on all sectors of society, economy, culture, and sports. And if the economy gets impacted by a pandemic, for example, in May 2015, MERS began in Korea, and throughout the 3 months, there was an estimated loss of 20 trillion won. SARS had 50 trillion won, H1N1 had 30 trillion won. Foot and mouth disease had 25 trillion won, and now COVID-19 is expected to cause much more economic damage. Fear is spreading more widely than the actual cases of patients, and it affects not only individuals, but also society, the economy, and the national brand. The impact on politics is also huge. No matter how advanced the development of science is, the response to emerging infectious diseases will always fall short. As such, we need to be well prepared for emerging infectious diseases. We always see a reproduction number index. The basic reproduction number is called R0. It indicates how many people a single confirmed person infects with a group that has no immunity, happening in the natural state. RT is the effective reproduction number. It indicates how many people it spreads to in the specific area when patients are rising. When we say R0, measles is the highest and MERS is 2.5 to 3.5. One person infects 2 to 3 people. It comes out like this, but when it's actually trending, we need the effective reproduction numbers from this area. Currently, measles has the highest R0. It can infect up to 180,000 people, and the threshold concentration of herd immunity is different. The higher the R0, the higher the herd immunity. In the case of measles, you need more than 95% herd immunity for it to end. Emerging infectious diseases and reemerging infectious diseases are being talked about. An emerging infectious disease is when a new pathogen infects a human body and becomes prevalent. And a reemerging infectious disease is when a disease decreased in the past but comes back. If malaria, tuberculosis, dengue fever, and measles decreased and come back and become prevalent, they are called reemerging infectious diseases. You can understand emerging and reemerging infectious diseases based on these concepts. AIDS in 1981 and the antibiotic-resistant bacteria Nipah virus, NIV, and swine flu in 2009. MERS in the Middle East in 2012, and COVID-19 in 2019. In the past, there was one emerging infectious disease in 2 to 3 years, but now we have 2 to 3 diseases in 1 year. That's the extent to which emerging infectious diseases are quickly and more commonly affecting us with greater impact. Another characteristic is that 75% of emerging infectious diseases are vector-borne disease and zoonosis disease. Zoonosis disease is when pathogens move between humans and animals, wild animals, and livestock. When we're in contact with wild animals and livestock, we get infected. And we take care of chickens, ducks, pigs, and cows to consume protein, right? And that's why it's difficult to control zoonosis disease. At the center, bats are often the cause. Then pathogens move to chickens, ducks, pigs, horses, cows, and camels, and then infect humans, an emerging infectious disease. On the left, you can see wild animals and bats cause the most emerging infectious diseases. Migratory birds, monkeys, chimpanzees. AIDS first came from monkeys and chimpanzees. So through a spillover, a longitudinal spread, it starts from animals like livestock, chickens, ducks, pigs, and cows to human infection. Or there are several vectors like mosquitoes and ticks in the middle that also causes human infection. Emerging infectious diseases are constantly spreading amongst wild animals, livestock, and humans, and becomes prevalent amongst humans, causing a pandemic. So each pathogen has its own natural reservoir, an intermediate host, and a propagation path. Bats are the most common. For bird flu, it passes through migratory birds, chickens, and ducks to humans. For Japanese encephalitis, it starts from pigs to humans, and sometimes there is a mosquito in the middle that spreads it more. Zoonosis disease is the main cause of recent emerging and re-emerging infectious diseases. That's why preventing and controlling zoonosis disease is blocking the emergence of infectious diseases and preventing a pandemic. So the Ministry of Food, Agriculture, Forestry, and Fisheries and the Center for Disease Control and Prevention should work together on zoonosis diseases. Restriction of livestock movement, and then controlling vectors like mosquitoes and ticks, sterilization of dairy products, and then vaccination. Rabies comes from the badgers and raccoons. So if we release bait vaccine into the woods and vaccinate badgers and raccoons, the human infection won't happen. This is the last slide. We're back to One Health. Looking at the Earth from the Moon, the Earth's ecosystem consists of humans, animals, and the environment. If we make a healthy Earth, the human race and the animals can be healthy too. But currently, Earth is warming from fossil fuels and burning coal, and the climate is changing, which increases vectors, therefore infectious diseases and destruction of jungles. Preserving the Earth's ecosystem can protect human health, animal health, and reduce environmental pollution. From this One Health concept, let's live by thinking about the Earth's condition, love the Earth's environment and animals, and reduce environmental pollution. This will be the message of this lecture.